Evaluating C, when we take a look, we want to evaluate log base 1/6 of -3 is equal to x. Hopefully you will recognize that we cannot evaluate the log of a negative number. However, if you did not realize that and you rewrote it as 1/6 to the x power is equal to -3, you cannot take 1/6 or any number to a power and get a negative number. When you rewrite D in the snail form as an exponential, it is 6 to the x is equal to 6. We're saying that 6 is equal to 6, therefore x is equal to 1. Another way to think about this is whenever you are taking the log of a number and its base, they are the same value. For example, log base 10 of 10, log base 9 of 9, log base 7 of 7, log base 6 of 6, the answer will always be equal to 1. If a base is not written, then it is implied to be base 10. These are all common logs. If the inverse of the exponential function is e to the x, remember the approximate value of e is about 2.7. This is known as the natural log function. One thing that you need to remember is that the e is a very special value. It is Euler's number, and it has its own special notation for the inverse, where the logarithmic form is technically log base e of n is equal to x, but we must rewrite log base e as the natural log of n is equal to x. So another way to think about this, as soon as you see the natural log, is log base e of n is equal to x. You can rewrite it using your snail that it is e to the x is equal to n. You cannot write the natural log as log base e. You must replace it with the natural log. You have two special cases here, that the natural log of e is equal to 1, because if I rewrite this, it is log base e of e, and remember what we talked about up here. If your base and what you're taking the log of are the same, this is always equal to 1. And if you rewrite this, which is log base e of 1 is equal to an unknown value, e to the x is equal to 1. Remember, this is a number, so you're saying 2.7 to the x power is 1. We said in 4a that that answer is 0. In the next few boxes, we are going to go over some basic properties. You must know these properties. You have to memorize them as you must apply them. We just stated here previously that the log or the natural log of 1 will always be 0. These properties will apply to either log base 10, log base 5, log base 7, and log base e. Here, log base 10 of 10 to the k, or whatever is in the exponent, will be equal to k. One example would be if I had log base 5 of 5 to the x plus 1 based on this property. These are the same, therefore this would be your answer. The reason why is because we have log base 10 of 10 to the k is equal to an unknown value. If I rewrite it as an exponential, this is 10 to the question mark is equal to 10 to the k. Just like 4D, if 10 is equal to 10, then our unknown question mark is equal to whatever is up here. Same thing applies to the natural log of e to the k, or whatever is in the exponent. This is the same thing as log base e of e to the k, therefore your answer is just k. In this case, the base of the exponential is the same as the base of the log, so I'm going to write it a little bit bigger so that you can get an idea. When this base and this base are the same, these are gone, and your answer is whatever you're taking the log of in the exponent, so the answer would be v. For example, if we had 7 to the log base 7 of x squared plus 1, the answer in this case would be x squared plus 1. In the case of the natural log, this is the same thing as e to the log base e of v, therefore the answer is v. Again, these are basic properties that you must remember. You must commit them to memory. Last page. Here we're going to evaluate without a calculator, and part of what will help us is if we rewrite as an exponential. This is currently a logarithmic expression. Set it equal to x, which then creates an equation. If this is really log base 10 of 10 to the square root of 43 is equal to x, rewrite it using your snail. You have 10 to the x is equal to 10 to the square root of 43. If 10 is equal to 10, then x is equal to the square root of 43. That's your answer. Set b equal to x. Rewrite it using your snail. 16 to the x is equal to 4. Whenever your base is a greater number and your answer is a smaller number, then you will be taking a root. What root do I take of 16 to get 4? The square root. The square root is indicated by the 1/2 power. In C, if I set this equal to x, we end up with the square root of 3 to the x power is equal to 27. Our objective in solving this problem is to rewrite with base 3, meaning 3 to the 1/2 x. This 1/2 is representing the square root. And what power do I take 3 to get 27? So now we end up with 3 cubed. This allows us to create an equation where we have 3 is equal to 3, therefore 1/2 x is equal to 3. Solving for x, we would multiply by 2, therefore our x value has to be 6 for this to be true. In D, there is no base written, therefore it's implied to be 10. You set this equal to x and rewrite it as 10 to the x is equal to 1,000. You ask yourself, 10 to what power gives me 1,000? Or you can rewrite 1,000 in base 10. If 10 is equal to 10, then x is equal to 3. We should know from our basic properties on the previous page that the log of 1 is equal to 0, but if you have forgotten, you would have the log base 10 of 1 is equal to x, so 10 to the x is equal to 1. Therefore, this has to be 0. If we are rewriting 3f, this, remember, is base 10, set it equal to x, so we have 10 to the x is equal to the square root of 10. Just as we did in C, rewrite so that your 10 is your base and the square root is the exponent, so 10 to the x is equal to 10 to the 1/2, so your answer is 1/2. Hopefully you remember the property that -3 is not within the domain of a logarithmic function, therefore this is not possible. You cannot take the log of a negative number. You can take the log of a number and your answer is negative, but you cannot take the log of a negative number. So to review, going from a logarithmic to an exponential, snail, 3 to the 4th is equal to 81. Same idea, my snail approach applies. The log base 4 of 64 is equal to 3. Here again, log base 125 of 5 is equal to 1/3. And finally here, 8 to the -2/3 is equal to 1/4. You must be very good at rewriting from logarithmic to exponential and exponential to logarithmic. In the case of the last 3 problems in 4, we are going to solve for x without a calculator. Because we're not using a calculator, there's only so far that we can get in our answer. Remember, this is log base e, so think about this as log base e of x is equal to 4. Rewriting, keeping in mind that e is a number, we're saying that our value for x would be whatever e to the 4th is. Since I do not have a calculator, I can not evaluate e to the 4th power because that's about as far as I can go. You need to think about this, though, as 2.7 to the 4th. If you were allowed to use a calculator, you could estimate that value. In the case of b, if I rewrite this as a logarithmic to solve for x, we would have log base e of 5 is equal to x, which is the same thing here as the natural log of 5 is equal to x. If I were to use a graphing calculator, I could evaluate the natural log of 5. At this point, I cannot. The last problem like this would be to evaluate the natural log of -5. Again, graphically, our graph has a domain, whether it's log base 10 or log base e, which is the natural log, The domain goes from 0 to infinity. In this case, because I'm asked to evaluate the natural log of a negative number, this is not possible because the value does not fall within the domain. One thing you need to keep in mind is that if you own a regular TI-83, your calculator will only evaluate in base E or base 10. If not, we would have to use what's known as the change of base formula. We will not be evaluating or reviewing the change of base formula, which was covered in Algebra 2. However, there is a way to evaluate a problem that is not base 10 or base E and that cannot be rewritten. For example, log base 4 of 7. If I set that equal to x, the first thing we would try is to rewrite it as an exponential, or 4 to the x is equal to 7. I don't know what power 4 has to be taken to get an answer of 7. Therefore, I can actually use the TI-84 Plus in this classroom to evaluate log base 4 of 7. I would go into the calculator, go into Math, which is right here, and in the mathematical menu, I'm going to scroll all the way down until I get to A, which is log base. When I press enter, this sets it up, so all I have to do is plug in the 4 and the 7. When I press enter, that would be my answer. That is the only way that you can evaluate this without going through the change of base formula.